In this video, we shall quickly go through the chapter Magnetic Effects of Electric Current. So, magnetic effect of electric current (MEEC) was given by a scientist named Hans Ørsted. So, according to him, whenever there is a current produced or passed through a conductor, there is a magnetic field generated. So, if you pass current, in this particular direction, or when you pass a current through a conductor, there is a deflection in the compass needle. So, you know what a compass needle is. So, whenever you pass a current through the conductor, there will be slight deflection. Deflection means the needle shifts either towards the right or the left, depending upon the direction of the current applied. So, that is what I meant to say as deflection in the compass needle. Now, after this, we need to know what right-hand thumb rule is. This is a very important concept that has to be understood in order to learn the future concepts. Now, according to the right-hand thumb rule, it basically gives us the direction of the magnetic field of current through a straight line. Now, I'm saying when I applied the current here, there is some kind of magnetic field generated. Now, for me, it is very important to know in what direction the magnetic field is generated. So for that, we use something called as a right-hand thumb rule. So what I do, I fold my hands like this, where your thumb represents the direction of the current. And wherever the hands is folded, that will give us the direction of the magnetic field. Suppose this is the wire you're considering. Now I am saying I'm applying the current upwards. So what I have to do is, I have to put my thumb in the direction of the current, and wherever my fingers have folded, that will be the direction of the magnetic field. So the fingers are folding inside, so the magnetic field will be about like this direction. So that's what I've done here. So I'm considering the current to be passing in upward direction. So my magnetic field will be in this direction. Suppose the current is in this direction, the downward direction. My fingers are crawling this side, which means what? The direction of the current will be towards this side. So that is about right-hand thumb rule. Next, let us just know what a magnet is, right? Now, so you have a bar magnet, which has a north pole and a south pole. Now we know like poles repel and unlike poles attract each other. And the poles, we can never separate the north and the south pole in a magnet. It has to be together. Now, it is also crucial for us to know the direction in which the magnetic lines flow in a magnet. So you have the north pole and the south pole. So outside the magnet, the magnetic lines flow from the north pole to south pole, as I've shown you. So if you can see here, the magnetic lines flow from the north pole to the south pole. Whereas inside the magnetic lines flow from the south to the north. And no two magnetic lines intersect each other. So I'll just repeat it. The direction of the magnetic lines in the magnet is from south to north, whereas outside the magnet it is from north to south. Now, no two magnetic lines can intersect. Now, closer the magnetic lines, which means what? Closer the magnetic lines are, greater is the magnetic strength. Farther away, the magnetic strength decreases. Now, we can also know the direction of the magnetic field in terms of clockwise and anti-clockwise. Okay. Now, if I'm saying the current is flowing in anti-clockwise direction, so this is an anti-clockwise direction, right? It is flowing that, then I can say the direction of the current is basically the pole is the north pole. So, easy way to remember this is like this. So, you just have to draw a circle, okay, and show the anti-clockwise direction of the current. So, current is going like this and coming like this is anti-clockwise. You just have to join the lines, and this means it is north. So, if it is south, it is going to be like this, right? Clockwise is like this. So, what is happening? It is going like this. So, you just have to draw S like this. So, it will come as inverted S. So, this will basically tell us the north pole or the south pole depending upon the direction of the current flow. Next, the next concept after your MEEC, that is the magnetic effects of electric current, you have something called as EMI. What is EMI? EMI is nothing but electromagnetic induction, which was given by a very famous scientist, Michael Faraday. Right? So this is the completely opposite version of MEEC. Not opposite, it is the reverse of it. So there we say when current passes, the magnetic field is induced. But here what we are saying, when there is change in the magnetic field, current produces. So it's exactly the reverse way. There we are saying current, whenever there is change in the current, magnetic field produces. Here, whenever there is change in the magnetic field, electric current produces. Now, we have something called as ammeter. So ammeter is an instrument which lets us measure the amount of current, and galvanometer is an instrument which tells us the amount of magnetic strength or how much the deflection is happening. Now, let us consider a coil. Okay, so we have a coil here, okay, connected to a galvanometer. Now what I'll do, I'll take a bar magnet. So this is a simple bar magnet. So what I'll do, I'll take a bar magnet and I will start moving it around the coil. So what happens when I start moving it around the coil? There is some kind of electric current produced, right? Which means what? This is nothing but the EMI. Now, what happens when I move the magnet faster? If you move the magnet faster, there is more deflection here. So, faster the movement, greater is the galvanometer deflection. Let's next come to left hand thumb rule. So, similar to right hand rule, we have something called as left hand thumb rule. So, let us just go through this briefly, okay? So, now, what you have to do is, you have to take the first 3 fingers of your hand, place them perpendicular to each other. So this is not an actual diagram, but let us just manage with that. So what I do is, I'll put my fingers or place my fingers such that each finger is perpendicular. So if you see, my thumb is perpendicular to this. This has to little go back, so this will also be perpendicular to this. So according to left hand thumb rule, if my first finger, which is the first finger, which represents the magnetic field, and my middle finger represents the current or the direction of the current, then my thumb will tell me the direction of the force. Now, let us take an example. So, I have taken a magnet, yeah, this is the north side, this is the south side. Now, as I told you, the movement of the magnetic lines inside the magnet will be from south to north, and outside it is from north to south. So, I have just put these lines which depict the the direction of the magnetic lines. Now, what I have to do is, I have to apply the left hand thumb rule in order to know the direction of the force. Now, the direction of the current is this side. So what I have to do, my middle finger has to be placed such a way that it shows the direction of the current, and magnetic field is this. So if I place it like this, if you see, my first finger is in this direction, right? And the current is going down. So I have to show it like this. I'll just repeat it again. What I have to do is, I have to relate my fingers to the direction here. So basically, this is the current, this is the magnetic lines, and this will tell me the force. So what I have to do, I have taken 2 magnets here, I have shown the magnetic lines as well as the direction of the current. So I have to place my fingers such a way that they're coinciding the direction in this diagram. So according to this diagram, the magnetic field is in this direction, so this has to be straight, correct? So now see, the magnetic field is straight, so I have to keep it in the same direction. Obviously, when I put this one, so the current is in this direction, so my middle finger is going down. So which means what? The force is towards the upward direction. So this is an important formula kind of thing, or it's a rule that we use to know in which direction the force is being applied. Now, the very important applications of your MEEC and EMI is the electric motor and the electric generator. So let us go through electric motor. So what is electric motor? Electric motor is something that converts your electric current to mechanical energy. Now, let us consider, again, this is a very simple diagram of an electric motor. Yeah, so this is your input, okay, and this is a magnet, and this is a coil, and you have the output fan. So you have placed a fan just to see just to see what exactly happens. So you have electrical energy. That's what I said. Electric motor is one which converts electrical energy to mechanical energy. So your input is your electrical energy. I've used a battery here. So output will be the mechanical energy. Now what does mechanical energy do? It will basically rotate your fan there. So what exactly happens here? Again, you have to apply your left hand thumb rule here. Now, I have placed 2 magnets here, the north and so if I am doing it separately, this doesn't mean I have a north magnet separately south. It is just one. In between that, you have a coil attached. So this is how the motor in general will also be there. Now, applying the left hand thumb rule for the above region. What does above region mean? This half region. Okay, now what happens? If you see here, the magnetic lines is in downward direction, correct? Because I've told you always the direction of magnetic lines is from north to south. So what your first finger represents the magnetic. So what I have to do, I have to place it like this, right? I have to place it like this, which means what? The current will come towards this side, which means what? The force is inward direction. Now, again what I'll do is I'll take the below region or the down part. What is happening? It will be the opposite direction. Why? Because the force will come outwards. Now what is happening to the magnetic? The current is in this direction. So what the current, I have to keep the finger such a way that the current is in this direction. So current represents the middle finger. So if I keep it like this, right? I have to keep it like this, perpendicular, right? And the magnetic field is in the downward direction. So I have to keep it like this. I have to place it perpendicular, which means what? The force is outward. Now, in the above region, you have the inward movement, and the below region, you have the outward movement. So when you have an inward and an outward movement, which means what? The motor starts to rotate. So basically, your electric motor works on the principle of left-hand thumb rule. Now you have something called as a generator. So generator is also a kind of instrument which converts mechanical to electrical. So it is exactly opposite of the working of a electric motor. So the only difference is that we try to study this using your right hand thumb rule, whereas you use your left hand thumb rule to study electric motor, whereas we use right hand thumb rule to study the working of generator. So what does generator do? It converts your mechanical energy to electrical energy. So see, if you can see the diagram, if you compare, it is completely opposite. So you had your output, mechanical energy. Here it will be the electrical energy. So what I'm going to do, again I've placed a coil here, and you have two magnets, north and the south. So which direction is the magnetic field? It is towards the downward. Now applying the right hand thumb rule. So what I'm saying, I'm going to apply the current, right? So this basically the folding of the fingers will give you the direction of the magnetic field, and this will give you the direction of the current. So what happens? This, I have to fold it like this, right? Because the magnetic lines are coming from down to, so I have to fold it like this, which means what? Current is in the upward direction. So what happens? When there is current flow, the bulb starts to glow, and thus you have mechanical energy converted to electrical energy. So these are some of the important applications that they will be asking in the exam. So the kind of questions or the possible questions that could arise from this lesson is, what is EMI? Yeah, and what is magnetic effects of electric current? Explain your right hand thumb rule, left hand thumb rule with an example. So when I ask an example, just take a simple magnet and show the magnetic lines and the direction of current, and you can explain by writing your own words. And they'll also ask the application, or they just ask, explain the working of an electric motor or a generator using left hand thumb rule or right hand thumb rule respectively.